In section 6.3, we are simplifying complex fractions. A rational expression whose numerator, denominator, or both contain one or more rational expressions is called a complex rational expression or a complex fraction. Our goal in this section is to simplify complex fractions. A complex fraction is simplified when it is in the form p over q, where p and q are polynomials that have no common factors. We have two different methods we're going to explore. In the first method, we simplify the numerator and the denominator of the complex fraction so that each is a single fraction. We'll perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the denominator of the complex fraction. So that's where keep, change, flip comes into play. And then simplify if possible. So for example 1a, you'll see that in the complex fraction, the numerator is already in a single fraction and the denominator is in a single fraction. So we can automatically go to keep, change, flip. We're going to keep the top, 2x over 27y squared. We're going to change the division to multiplication, and then we flip the second fraction to 9 over 6x squared. From here, this just becomes a multiplication problem that we need to simplify. So we can't simplify anything on the top and bottom of the first fraction, but we can on the second one. We can take a 3 out of 9 and 6, and we are left with a 3 on top and a 2 on the bottom. We can cross multiply. I have an x on top and I have 2 x's on the bottom, so that means I just have 1 left over. And I have a 2 on top and a 2 on the bottom. I can also simplify the 3 and the 27. So 3 goes into 27 9 times. And so after all the simplification, we only have a 1 left on top, and on the bottom we have a 9, an x, and a y squared. Let's look at the second example. We have x over y squared plus 1 over y divided by y over x squared plus 1 over x. We need to make the numerator and denominator as a single fraction so that we can use keep, change, flip. So looking at the top portion, my LCD here is going to be y squared. The first fraction already has the y squared in the denominator, so we don't have to change anything about this one. But the second one is missing an additional y. So we need to multiply by y on the bottom and the top. So we end up getting x plus y all over y squared. In the denominator, the LCD is going to be x squared. So just like the top portion, the first one we don't have to fix because we already have x squared in the denominator. But the second fraction, we're missing an additional x. And so that's what we need to multiply by on the bottom and the top. And we end up getting y plus x over x squared. And we have our big fraction bar in between these two. So now we're going to use keep, change, flip. We're going to keep the top, x plus y all over y squared. We change division to multiplication, and we flip the second fraction, so we have x squared over y plus x. Now what we want to do is we're going to try and simplify either by cross multiplication or on the top and bottom. So we have an x plus y and a y plus x that we can cancel. And so what we're left with is x squared over y squared. The second method is when we multiply the numerator and the denominator of the complex fraction by the LCD of the fractions in both the numerator and the denominator. Then we simplify. So looking at example 2a, we have 5x over x plus 2 divided by 10 over x minus 2. So looking for the LCD of the entire complex fraction, we're going to have x plus 2 times x minus 2. And so that's what we want to multiply the top and bottom of the complex fraction by. So we have our 5x over x plus 2 times our LCD, which is x plus 2, x minus 2. And so what's going to cancel here is the x plus 2. And in the denominator, we have 10 over x minus 2. And we multiply by the LCD. And so what ends up canceling here is the x minus 2. So on top, we have 5x times x minus 2. And on bottom, we have 10 times x plus 2. So what else can we simplify? Well, we have a 5 on the top and a 10 on the bottom. So 5 goes into 10 2 times. So we end up with an x times x minus 2 on the top. And on the bottom, we have 2 times x plus 2. And let's go ahead and try one more. This is the same one as we did with method number 1, but we're just going to do it with method number 2 now, so you can compare the procedures. So we want to find the LCD of the entire complex fraction. With the previous method, we found the LCD of the top and the LCD of the bottom, but we just want to combine those together, and the LCD of the entire complex fraction is x squared y squared. So we're going to multiply the top and bottom by x squared y squared. So we have x over y squared times our x squared y squared plus 1 over y times x squared y squared. In the first fraction, the y squareds cancel, and in the second one, only a single y cancels. In the denominator, we have y over x squared times x squared y squared. And we have 1 over x times x squared y squared. And so in the first one, the x squareds cancel, and then in the second one, only a single x cancels. So what we have left over is x times x squared, which is x cubed. And then we have 1 times x squared times y, or just x squared y. And in the denominator, we have y times y squared, which is y cubed. And then 1 times x times y squared, or xy squared. We can factor out and x squared in the numerator, and I'm left with x plus y. And in the denominator, I can factor out a y squared, and I'm left with x plus y. So what I can cancel is the x plus y's, and I'm left with x squared over y squared.